Alright, what's up guys? Welcome back to another intelligence maxing episode. So it's day 81 now, almost 100 days, just 19 more days to go. But I have this quiz tomorrow for computer architecture, so I'm going to take some time today, 30 minutes before class, to just go over some practice problems. Alright, let me try to see. I had some uploaded earlier. Now you can just only see my live stream. Just gonna load into my class real quick and then download the problems. I'm getting cooked in this class, by the way. The class average is like a 60%, I think. Let's see. Practice. American tests. Alright, here we go. Let's download this. Oh. Okay. So we have a loop here containing two branches, B1 and B2. B1 is executed and then B2 is executed. So they're sort of consecutive branches. Branch actions outcomes are provided in the table for each loop iteration. Show in each loop iterations the state of the branch predictors used for predictions and the predictors. Right? Used for predictions and the predictions. Okay, it's a bit confusing. Note that the predictor states will be updated after the actual branch directions are determined. Okay. Assume that B1 and B2 predictions do not interfere with each other, alright? So one does not, they're sort of mutually exclusive. Actually, I don't know if mutually exclusive is the right word, but one doesn't cause, or doesn't affect the other, okay? So all predictors are initialized to strongly not taken. And at 3, the correlation bits are initially set to not taken. And the rightmost bit of the global history represents the actions from the most recent branch. Okay, so it seems like here we have a 2-bit global history, this right here. And then we have 2 bits two global correlating predictor with a 2-bit global history. So I think that means we have 4 prediction states, and then each of these prediction states we have two bits to represent the state. So predictor A, right? Local history. So there's 2 different things. There's global and local. Okay, let's take a look then at the global. Table. Yeah, this is going to be a tight table, but let's give it a try. So iteration 1, 2, 3, 4, exit. Predictor state. And prediction outcome. So this is actually, let's see, we need 2 tables. So we need one for branch 1 and the other for branch 2. T, okay. So that's actually good. Branch 2, so this is taken, and then not taken. All right. so initially it seems like the predictor state is... Alright, let me see something actually, because I want to make sure the homework I submitted was actually legible. Nice. So everything is originally not taken. I guess it'll be like this. So 0, 0, 0, 0, 0, 0, 0, 0. Right. And so our prediction then is just not taken. And I want to say, so each branch has its own predictor state, so independent predictor state. That means this should be unchanged and not affected by. Say, so this is 0, 1 now. Okay, so prediction state 0, 0, so this would be 0, 1. Right. So there's two things going on here. So in the first iteration, we've set our two predictor states for each branch to be not taken. And the first correlation global, I think these are the global history. What do you call it? The correlation bits, or global correlating predictor. So these are initially set to not taken as well, but we do have the outcome of our branches taken, so that then affects the correlation bit for branch 2, and so this becomes a 0, 1 bit predictor, and the outcome here is also taken, so I think then this becomes 1, 1, because we have a taken and a taken now. And we also, in this case, let's take a look here. So this means that in the next iteration, so we have this predictor state indexed by 0, and we have to flip the bit to 1 because of the taken. All right, so this is our new state. Okay. And then we make a prediction here. So the prediction is now 1, 1. And yeah, that means it's strongly taken. Right, so we should take it. I have to double check on what that actually does. But the outcome here is not taken. Okay, so this means our new global correlator is 1, 0, but our predictor state we have to get from the previous problem or the previous iteration, and so in this case we index our predictor state by 0, 1, which is just 1, and then we flip the rightmost bit to 1 to get taken. Actually, yeah. I won't do that. Okay. we could do this. We've indexed our in iteration 2. So we've indexed this by 3, 1, 1. So this will change the rightmost bit in this, which is just 0. So it stays the same. And then now we could take the prediction from this global predictor, global correlation bits, and then we see that this is also not taken as well. Right. I have to double check this real quick. So start here. It's not taken, right? So we've taken. Then we flip this to 1. Taken. Not taken. Okay, right. So 0, 1. Okay. But this is taken. So what we need to do then is 0, 1. There we go. So we modify. The most recent outcome was a taken, and so we modify the rightmost bit to taken. Okay. But now this changes because now it's not taken. But let's go to this real quick. So we have our prediction bit here, which is just 2. So we index 2. We change this to a 1. Okay. I think this is on the right track. Change the 1 here. Okay. And so this is not taken. So we 1, 0. There we go. Okay, so 1, 0. Then I think on the final iteration now. So we're at 1, 0. It's taken. So we have 0, 1, 0, 0. Yeah, so we don't modify anything here because not taken. Alright. And our prediction here is we've inserted, so we've taken this branch. Oops. Yeah, this is confusing. It's very hard to wrap my head around. Okay. Taken and not taken, right? So we have to look at this one and this one. This one, that one. When we look at this, what do we look at? We look at not taken, taken. Then when we're looking at this, we do taken, not taken. So it will be also 0, 1. Okay. And so our final predictor state will be 0, 0, 0, 0. Okay, I think this is the right way to think about it. So now we could take a look at this, and we've indexed. Yeah, so this is the same It's the same here. But now our prediction brand is 1, 1 because it's taken and then taken. So this becomes, we're gonna modify this rightmost bit and it stays the same. Okay, so I think this should be the final 2 states of our branch predictor at the end of the 4 iterations. So let's try to double check our work here. We start with 0, 0 for all 4 states of our 2, 2. I don't know, what do you call this? I guess it's our 2, 2 branch prediction scheme. And each of these branches have their independent sets of predictors. So we start with branch 1. So B1 is executed first. 0, 0. And then the outcome is taken. So we have a taken, not taken now. And we need to modify, in this case, the first or the 0th index. And we change that to 1. So that makes sense, because now we've taken it and we just change it. So that means for the next global predictor, we add a 1. And so it's going to be taken, not taken. We can index our predictor by this correlation bits and then flip that to a 1 because it's taken, right? And so now we have a global correlation bits of 1, 1. And so this will modify our 0th or our 3rd index. And because it's not taken, we just leave it the same. Okay, yeah, that's fine. So we don't change anything here. Okay, so now it's not taken. In our next move, so we have 0, 1. And this will index the 2nd bit here. And you'll see that the outcome is taken, so we do eventually switch the predictor state. Okay, so now we go back to iteration 3 on branch 1. And now we could take a look at, okay, so we're just on iteration 2. We've taken the branch, and we also have not taken here. So that's just going to be 0, 1. And that indexed the 2nd. And we don't do anything because it's also not taken. So it's already 0, we leave it as 0. Then moving on to the 3rd, we have, in this case, not taken, taken. So that'll give us 0, 1. And that'll index the 2nd index of our predictor states. And the outcome is taken, so we flip that. And now on the last iteration, we have 0, 1 here. The reason is because we have a taken and then not taken. So this will give us 0, 1 that index the first. Yeah, it's index 1. I shouldn't say first because it confuses with 0. But this is taken, so we end up flipping it to 1. Okay. And then the final part is we have a taken and we have a taken. So that should give us a prediction of 1, 1. And this indexed the very last bit, and we just leave it the same. It's not taken. So let me double check to see if this is right, because I could be kind of saying things out of my ass here. Yeah, it seems like I'm not doing everything fully right. Okay. So I was able to get oh, okay, we do Wait. Okay, so we do need to add a 1, 1. I forgot that. Because we had 2 taken outcomes, I think. Or 2 predictors. Okay, so... But I think everything else should be right. Okay, so yeah, I should be highlighting both of the bits, so that's important to know. But I think the general idea, so index this, right. I'm gonna highlight. Taken. Oh, but I didn't get the prediction right. Why is the prediction always not taken? Okay, so you just look at the predictor values then. I guess that makes sense. Okay. So this is kind of misleading. This is the prediction, call it history, bits used. Okay, and then prediction, so we not taken, and then not taken. Yeah, all of these are not taken, which is rough. But that's just the way life goes. Oh, let's see. How do I delete this column? Alright, I don't know. It's too I can just actually prediction. Okay, here we go. Nice. Alright. So I guess this is a weak or strongly, or a weakly not taken. Alright. Branch prediction. So that's good. Now we have to, so this is assume the following, because this is 2 global correlating predictor with 2-bit global history. Oh god, I spelled that completely wrong. Right, and then branch addresses are used for accessing BHT, the branch history table, which I don't fully understand what this means. What does this mean? I don't know. I'm gonna be honest. Okay, but let's try this. So predictor A and then predictor B. So predictor B, so it's also a 2 local predictor with 2-bit local history, so that's the keyword here. And then branch addresses are used for accessing BHT. Okay, so I think we could just straight copy and paste this in here, and then we'll just clear. Oh fuck. Okay, nice. So let's just copy and paste everything here, and then we'll work backwards. Is this the same problem? So T, NT, NT, TT, TN. Okay, yeah, it is. Alright. So now we have our two independent sets of history bits, because they're all local now. So 2-bit local history. So we all start with 0, 0. And I think this is slightly easier now. Taken. Alright, so this stays the same. We can just go through each of these one by one. So that's not taken. Okay. And then we index one by one. So now it's just 1, 0. So not taken, taken. Alright, so yeah, instead of this, it'll now be this. Okay. 1, 0. And then we have 2 not takens. So that becomes 1, 1. This is a taken. So all of these predictions are still not taken, right? But oh no, this would be 0, 0. So now this would be 1, 1. Okay, here we go. Nice. Okay, not taken, predict. So the prediction, taken outcome. So this becomes, oops, 0, 0, 1, 0. Then we do 1, 0, 0, 1. There we go. So it's actually this that gets affected, and this will turn to. Oops. So instead of this being bolded, there we go. So now we have that. It's still not taken prediction, but now we index number 3. Okay. So it'll be 0, 1. Nope. And that'll be 0, 1. But in this case, we also history bit is 1, 1. So we're going to change this again. We're going to change it back to 0, 0. Okay. So I think this should work now. Yeah. Let's just go through branch 1. So start out with fresh predictor states, all not taken. We make a prediction of not taken, and the outcome is actually taken. So the history bit, because in the previous problem statement I said that we just assume the initial history bit is just 0, 0. So we index our predictor state by 0, flip the bit by 1, get to our next state. The next history bit then, because we're using local, is now 0, 1, because we have taken and then not taken. So we then index this. Nothing changes because our prediction and our outcome are both not taken. Really, it's more important that our outcome is not taken. Then number iteration 3. So we have not taken, taken. So our history bit is 1, 0 now. And nothing changes again. Our prediction is also not taken, and our outcome is not taken. And then finally, in our last iteration, we index 0, 0, but this time it's predictions are not taken, but the outcome is taken. So we get 1, 1. Oop. There we go. Predictor states fresh 0, 0, 0, history bit 0. Okay, taken, not taken. Flip this to 1, right? And then becomes 1, 1. Flip this to 1. And then 1, 1. Flip this back to 0. Let me just get this. Yeah, I think that works. So I'm gonna try to.
DC, what's up?
Hey, what's up, Mary? Okay, let's see if this is right. So 0, 1, 1, 1, 0, 0. Yeah, I think it looks good. Okay, I do have class now, so I'm going to end the stream here, but thanks for tuning in, guys. I feel like slightly understand this branch prediction stuff a bit better. I have a quiz tomorrow on it, so I better understand it. But thanks for tuning in. Catch you guys in the next one.